Hi everybody, thanks for being here. I'm Sébastien Deleuze. I'm coming from Lyon in France. I work for Pivotal as a Spring Framework committer. I also take care about the Kotlin support in the various projects of the Spring portfolio, and I'm an organizer of a Mixed conference. Today, we are going to talk about Spring Boot, but in a different way. We are going to use Kotlin instead of Java. We are going to use functional configuration instead of Java config, and we are going to compile a Spring Boot application into a native executable via GraalVM. So that's still Spring Boot, but in a different way. A quick safe harbor statement, because I'm going to talk about a lot of forward-looking stuff that may or may not happen. And I would like to start before talking about the new, fancy new stuff about where we are now, what you can use in production. I believe that Kotlin allow Java developers to leverage their existing skills to write shorter, safer, and more expressive code. And I think that's one of the main reasons why it's successful. Obviously, there is a lot of Kotlin developers that are coming from Android because Google chose Kotlin as the main and official Android language. So Kotlin developers are a lot of Kotlin developers are coming from Android world. But also on server side, we begin to see quite some traction, especially on Spring side. And I think that's for that reason. Kotlin-wise continue. Kotlin has overtaken Scala in terms of question on Stack Overflow. It's also the fastest growing language on GitHub, so we clearly see that the trend is strong. But I would like to put things in perspective. If we compare that to Java, really Kotlin is still far away. But I think the GVM landscape has changed. Until now, we had Java and the other languages. And now we have two major languages, Java, which will remain the leader language. But Kotlin is the second, and I think the others are in another category. So that's pretty interesting, and that shows that the GVM landscape is healthy, and I think that's a good news for the GVM. Kotlin 1.3 has been released recently. It brings stable coroutines, so it is advertised as stable coroutines. I would say that half of the coroutines are stable. Everything that is about channels, about receiving multiple results, is not stable yet. It's still experimental. So, but you can begin to use it for asynchronous values. Kotlin deals with multi-platform, so Kotlin is not only about GVM. Kotlin GVM is used for server-side, for Android, but there is also Kotlin JS, which is used to develop front-end application, and Kotlin native, which is about using Kotlin to develop application with libraries coming from C and C++ world. And with Kotlin 1.3, it has reached the beta stage. There is also other experimental support for other features like inline classes and other minor features. If you want to learn Kotlin, I would advise you to go to try.kotlinlang.org. There is some small exercise that you can do, especially if you are already an experienced Java developer. I think that's a good idea. And Ben Cat has recently announced that he is writing a Kotlin book, Programming Kotlin in the Pragmatic Programmers collection. It's not finished yet, but I believe you can already access to the in-progress online version. And I think that's a pretty good book that covers all the features until Kotlin 1.3, including coroutines. Also, I think Ben Cat writing a book on Kotlin is also quite significant for the language. So Spring Project provides first-class support for Kotlin. We have worked on that for more than 3 years now. And I think we can safely say that Spring provides first-class support for Kotlin in addition to Java. If you have not seen that yet, this is a Spring Boot application with Kotlin. So you can see that you have the same structure than in Java. You still have your @Spring Boot application annotation, @document for your data domain, @REST controller, @repository. But at the same time, you have shorter code. You can leverage Kotlin features like, for example, null safety everywhere to avoid a null pointer exception at runtime. You can use this short syntax in data classes where you can define at the same time the constructor and the properties. you can see that the created parameter in the user class is using optional parameter with default values. So instead of defining an overloaded constructor method, you can directly define optional parameter with default values. And if you just provide email and name, the created parameter will automatically take no value. So you can see that's a clever way, an expressive way to define your API. And you can benefit also to about type inference, about shorter code, about Kotlin extensions. So the idea is that you can leverage your existing Java skills, but write shorter and more expressive code. If you want to learn how to build Spring Boot application with Kotlin, I have written a very complete tutorial. It is available in spring.io. So you go to spring.io. In the guides, you search Kotlin, and you have a tutorial which provides everything you need to know to build a regular Spring Boot annotation, a regular Spring Boot application with annotation using Kotlin. Be also aware that we have a strong focus on optimizing Spring Boot startup time and memory consumption. We have recently released Spring Boot 2.1, and the good news is that just by upgrading from a previous Spring Boot version to Spring Boot 2.1, your application will start faster and will consume less memory. You have nothing to do. As usual in Spring, we take care about backward compatibility, and just by upgrading to the latest version, your application will be more efficient. We have done a bunch of optimization and profiling on Spring Framework and Spring Boot, and we have found some optimization that we have put into this latest version. So yeah, feel free to upgrade. I think it worth too. I guess you have heard about that. Spring now supports a reactive stack with Webflux and data. For predictive scalability, regardless of the latency, that's especially important when you develop microservices where you have to request data from the outside, so it generates some latency. And we have also bin definitions that are, in addition to XML, which is the old way to define bins in Spring, and Java config, which is currently used by everybody, including Spring Boot. There is a third way to define bin definition, which is a functional way using lambdas. So this is a new feature from Spring Framework 5. And Spring Framework 5 also introduced functional bins and router API with dedicated Kotlin DSL. So you can see in this example that's already usable in Spring Boot. You have this bins DSL, which allow to define a bin specifying just the class, and then the foo bin will be automatically auto-wired, so all the parameters will be automatically auto-wired if there is constructor parameters. You can also specify yourself how do you build this bin by providing a supplier. So for the bar bin, you are providing yourself a lazy way, a lazy supplier that will be used by Spring at the right time when building the bin graph to instantiate that bin, okay? And that gives you full flexibility to pass yourself some custom parameters, use a reference from another bin, or even a collection of bins. You have the full power to do what you want in this supplier. And there is also another DSL, which is a router DSL, which allows to define basically mapping with this kind of syntax instead of @request mapping annotation. Okay, so this is currently usable in Spring Boot, but I mean, you see that's a kind of mix between annotation and functional API. And why this is usable right now, I will just advise you to use the usual annotation-based programming model because that's consistent. But I'm going to show you what you can do with some upcoming stuff. So while working on that for 2 years, I had a few open-ended questions in mind that I would like to share with you today. The first one is, what would look like Spring Boot if it was designed natively as a Kotlin idiomatic framework? We all know that Kotlin is a good citizen with the Java ecosystem, so building a Spring Boot application using Kotlin with the current annotation programming model works pretty well, and that's perfectly fine, and there is nothing wrong about that. But maybe if we would have designed Spring Boot natively for Kotlin, which has a mindset a little bit different from Java, we would have used different ways of configuring things, for example. Another question, could we provide something for developers who prefer declarative configuration instead of auto-configuration and conventions? Again, there is nothing wrong about auto-configuration and conventions, and Spring Boot is just amazing in doing that, but it's a matter of diversity and tastes. Some people prefer declarative configuration where I can basically every feature enabled is explicitly declared. I can read my configuration. I have no surprise, and I am in control of everything. That's a different way. That's not worse or better. It's different. Could we use lambdas for configuration instead of annotations? Can Spring applications be even more lightweight? Could coroutines make Spring reactive stack usable in a more imperative fashion? We provide this new reactive stack with Spring Data Reactive, with Spring Web Flux, and it's very powerful. And the functional API and the reactive API has a lot of benefits, but that's not a free lunch. You have to learn a new way of writing your code. And some people like that, some people don't. For some use case, it's perfectly relevant. For example, when you deal a lot with streaming and you have to do a lot of complex transformation. But if you are just building a basic CRUD application and you still want to benefit of our scalable reactive runtime, I mean, it should be possible without having the cognitive load to learn a new style of API. So maybe coroutines could help in that field. And the latest silly one, could we compile Spring Boot application to native executables? So that's to begin to answer to this question that I created a few months ago, Spring Foo. So Spring Foo it's not a new top-level project. I'm super clear about that. It's an incubator intended to mature experimental feature before inclusion in top-level project like framework, boot, data, etc. So it's a place where we are experimenting ourselves at Pivotal, but also with the community. There is already more than 10 external contributors. In fact, the idea of Spring Foo came after a Java user group at Montpellier discussing around a beer with Thomas Girard, the local Jug leader, and he read some blog post I wrote about functional beans definition, etc. And we discussed about that, and in fact, this is somebody from the community, Thomas Girard, who wrote the first prototype of what became later Spring Foo, so that's interesting. And yeah. So I'm going to talk about the 4 main features that are in Spring Foo. There is others, but I would like to focus today on the 4 more important. The first one is Kofu configuration. So Kofu is for Kotlin and functional configuration. It's an explicit configuration model via a Kotlin DSL. It is based on a Spring Boot infrastructure. So again, I want to be super clear. Spring Foo is about leveraging Spring Boot infrastructure to provide a declarative way to configure it. It's not something outside of Spring Boot. It's really leveraging all the Spring Boot infrastructure. No features are enabled based on classpath detection, so you have to declare explicitly the feature. It is both declarative and programmatic. Declarative because it's a kind of document, but it's also code, so you can use if, for statements. You can do what you want. You are not limited. It has faster startup and lower memory consumption, minimal reflection and annotation usage, and it's pure lambdas, no CGLIB proxy. So you remember the previous code example. This is a Spring Boot application with the Kofu DSL. So you can see that we reuse the beans and the router DSL that are already currently present in Spring Framework 5, but we introduce a new application DSL, which will provide you the possibility to call various methods to configure in a declarative way your application. So you have beans, you have server, you can declare router, you can configure Spring Security. You have everything available with autocomplete, and that's a kind of way of configuring things. So bean foo is still declared. We declare with Kotlin a bean of type foo. I can also use the supplier variant. I can also use bean scanning if I prefer to use it. But it's explicit. It's not automatic. You have to specify explicitly what package you are using. And we are reusing this router DSL. Configuration as code is interesting because you can basically know what your application is doing just by reading the configuration. You can compose it, you can debug it, so you can put a breakpoint in your configuration and know if it's called or not. You have full autocomplete and documentation into your IDE, so you don't have to read a lot of documentation. Basically, it is self-documented, it is discoverable, yeah. So to quote Jürgen Oller, which is in this room, functional beans definition is the most efficient way to declare beans in Spring. And I think that's another benefit of this declarative approach is that it allows us to go faster. So I have shown previously the figures about the performance improvement bring by Spring Boot 2.1. If we use the very same set of features using a functional bean definition instead of Java config, basically your application go faster and consume less memory. That's not, I mean, it can be understood because we don't have to interpret annotations. Everything is just lambdas and code, and it's super fast. But it's interesting to see that another benefits of this functional and declarative approach is that you have a more efficient application. I also believe that Kofu could be a way for Spring Boot to reach developers coming from other backgrounds, Kotlin, Go, Node, Ruby, etc. So that's maybe a way to reach a new kind of developers. The second features I would like to describe before a demo is coroutines. So coroutines are Kotlin lightweight threads. By lightweight threads, I mean you can create a huge number of concurrent coroutines. It allows to write non-blocking code in a kind of imperative way. So if we compare Reactive API and Coroutine API, for a single asynchronous value in Reactive world, I will use mono. In the regular JDK world, I will just use completable future. That's the same. And in Coroutine world, I will just write a method that returns t, and I will mark this method as suspendable. So this is a suspendable function that returns t. And you can see that using some syntactic sugar and other things at the language level, we can just use t without any wrapper for asynchronous values. When I say that coroutines are not final yet, it's because cold streams are not supported. So cold streams are asynchronous iterables. So basically, this is a collection of fixed size, but you can begin to process elements. When you start, you receive the first elements. You don't have to receive all the elements like in a regular collection or a regular list. In Reactive world, we use Flux for that. In Coroutines world, there is nothing yet available. Kotlin team is aware that we really need that, and we are not the only ones, so they will provide that shortly, I think beginning of next year. So it will come shortly. For hot streams, so hot streams are basically something you subscribe and you listen some events and then you unsubscribe. We are still also using Flux in Reactive world, and in Coroutines world there is receive channel. And when you are doing some kind of async transformation, you see that in Reactive world we use flat map, while in Coroutine world your code will look like more imperative. So I don't say that all your code will look like purely imperative. Really, coroutines is not magical, but it's especially when you deal with asynchronous values, it allows you to write a more imperative code. So the scope of the coroutine support we are currently incubating into Spring Foo is Spring Framework, Webflux, Server, and Clients, Spring Data MongoDB, and a new project which is called Spring Data R2DBC. So R2DBC is an effort created by Pivotal to implement reactive SQL. So we currently have PostgreSQL support, and R2DBC is in fact has nothing to do with Spring. Okay, so you can use R2DBC in other technologies. I think the Kotlin guys are currently looking at to leverage it directly. And there is a Spring Data project that allows to benefit from R2DBC, which is this Spring Data R2DBC project. And I'm currently working on Coroutines API on top of that. Spring Data R2DBC is similar to another project we have recently created, which is Spring Data GDBC. The goal is to provide a more direct access to SQL by allowing you to write directly native SQL queries. So this is not a full-blown ORM, but that's a more simple solution that gives you more control. And we are going to manage coroutine support like we manage any other reactive APIs like Eric Java or completable future. So it's basically the same for us. So enough slide. We are going to do a demo of a Spring Boot application with Kofu. Okay, so the first thing to notice is that this is a regular Spring Boot application. Okay, I'm using the Spring Boot starters. I have additional dependencies on Spring Foo because these things are still incubating. So, for example, the coroutine support that may ended up in Spring Framework is currently with this dependency. The coroutine support for Spring Data R2DBC is also a Spring Foo dependency, and the Kofu DSL is another dependency that leverages Spring Boot infrastructure in a functional way. Okay. But the idea is that you use start.spring.io to create a Spring Boot application, and then you add these additional dependencies. So we are going to start by writing a main. Okay, that's like a usual Spring Boot application. We have just a main, and then I'm going to write this, I'm going to use this application DSL. So this is my starting point. I'm describing in a declarative way what there is in this application. You can see that I have autocomplete for the various features. So for example, if I want to configure logging, I do that. I want to configure the level. I have a good experience because I'm leveraging the IntelliJ ID features to configure my application. You can see that this class's log level is just Spring Boot log level class. Okay, it's not about reinventing the wheel. We are just configuring Spring Boot in a functional way, and we are reusing every Spring Boot infrastructure that we can. So here, okay, we configure debug. We are going to define in a functional way properties. So this is a functional equivalent of add configuration properties. And we are going to import two configurations. So like you don't put everything into a single class in Spring Boot, you have various add configuration for various parts of your configuration. With Kofu configuration, it's also about a modular configuration where you can just enable the data part or just the web part, or you should have fine-grained control on what you enable. So I'm going to add this configuration for only the data part. So you can see that I declare beans just for the user repository. So here I should put only the beans that are relevant for my data parts. I can declare it directly like that, or I can use some bean scanning capabilities. Here I'm defining with a listener an event that will be triggered when application ready event will be raised. And here I'm configuring R2DBC. With this DSL, I enable coroutine support, and I could also configure, customize host, password, port, etc. Okay, here I'm just using the default, and I'm using a PGSQL database. I'm going to create the repository. So here I'm using a coroutine version of the database client. So it's interesting to notice that Spring Data R2DBC provides two ways, basically, to write your code. The first one is the usual repository pattern that you all know if you are using Spring Data. Okay, so this is based on annotation, and this one is a more functional approach where you can use a database client, which is a functional API to describe what you want to request without using annotation. I'm going to create the user. I'm a lazy man, so I'm using live templates. Okay. So you can see that here I'm writing the requests, okay, and I'm describing it with a functional API. Maybe later we will provide more capabilities to write SQL requests with type-safe API, but for now we are just writing that like that, and that gives you the opportunity to directly call native PGSQL capabilities. We are also working on the support for other databases, and you can see that these methods are suspendable. Okay, so that means everything is asynchronous. Here I'm getting, for example, it's a suspendable function that returns a user. That's like a completable feature of user, but without having to add the noise of a wrapper. As I said previously, we don't have yet a type to deal with call streams in coroutines. So for now, I'm returning a suspendable function of lists. But when I will have the proper type in coroutines, I will use directly that to be able to begin process elements as soon as they are received. So it's not just about being asynchronous, it's also being reactive. That means that if I receive 100 rows, I will be able to begin processing them, these rows, as soon as the first rows are coming. There is also transaction support and other things. So that's okay for the repository part. Now we are going to configure the web part. Same principle, I declare in my configuration block only the bins that are relevant for the web parts. So here I'm declaring a user handler. So with the functional API, with controllers, we had at the same place mapping and the handler parts. And here we have splitted things. So here we have just the handling side, okay, which is using a coroutines version of our reactive infrastructure. So here I'm just serializing the users with JSON. Here I'm using a mustache template that will display an HTML page, and here I'm just printing a basic configuration. So this is for the handler parts. Then I will write the router. So here I have the router like that. You can use more complex request predicates, but that's a simple one. I'm going also to add okay, to configure that. And I think that should be okay. So to run it, I'm just running my main method. Okay, and so you can see that, okay, I have my mustache view, I have my configuration endpoint that is working, and I have my JSON API that is working. Now, let's take this example. I see this JSON output, and now I would like to add pretty print, okay, to have something nicer to view and debug. So I can go there. You can see, okay, here is my web configuration, and you see that Jackson is just a basic method with no parameter, but in fact, for each of these, there is a variant where you provide a lambda, and then you have everything to configure that in a fine-grained manner, discoverable. So here I see indent output, okay, equals true. I will restart the application. And then pretty print is taken in account. So again, I think one of the big benefits is that this API is discoverable, and you can configure cores also. You can configure various other things. You can see that the codec configuration is explicit. So while in Spring Boot you have a bunch of codecs configured by default and other ones that are automatically configured based on what is on the class path, and sometimes that creates some surprises. Here you are in control, so by default there is just string and resource codecs configured. And if you want to add one, like Jackson, you declare that. If you want to change the order of the codecs, you can do that. You are in control of what you are using in terms of feature. Okay, let's continue. Let's continue the talk. So back here. Okay. So that's nice for people using Kotlin, but Spring Boot, the vast majority of Spring Boot users are Java developers, and they maybe would like also to benefit of this functional approach, to have better efficiency, to have this kind of declarative approach. So I work on Jafu. Jafu is for Java and functional. And this is basically the equivalent of Kofu for the Java world. So obviously, the syntax is a little bit more verbose. We don't have reified type parameters to avoid type erasure. We don't have Kotlin extensions to provide a more extensible API. But using builder patterns, using this kind of pattern where we configure the application using basically consumer of DSLs, we can provide a pretty good API to configure in an explicit way application also for Java developers. And I plan really to develop Kofu and Jafu with the same level of functionality, so they will leverage the same basis Spring Boot configuration infrastructure, and you will have the choice to use Java or Kotlin. Now let's talk about native executables via GraalVM. So the idea here is to be able to compile Spring Boot application as native executables. So GraalVM is an R&D project started, I think, more 7 years ago at Oracle. So GraalVM is not only about native images. When we heard about GraalVM, people usually talk about this native images capabilities. In fact, GraalVM is a new generation virtual machine. It provides various capabilities, including polyglot capabilities to make various language interop in a good way. And SubstrateVM is a sub-project of GraalVM, and this is SubstrateVM that allows to compile a GVM application to native executables. The advantage is that you have instant startup and low memory consumption. Obviously, there is also some drawback. For example, a native executable is not able to optimize itself like the GVM does. So for long-running jobs, maybe in terms of performance, regular GVM does better. But it's a matter of trade-off, and you will be the idea will be to give you the choice about the running platform. It supports most of the reflection. Not everything is supported, but GraalVM, SubstrateVM is pretty good to support reflection. That requires configuration, so that does not work magically. But with the good configuration, most of the reflection API is supported and work. SubstrateVM is pretty young, while GraalVM, the global project, is close to reaching the GA level. I think SubstrateVM is still pretty young. It has quite a lot of bugs because there is so many different Java libraries in the ecosystem. Not everything is supported. So maybe some part of the ecosystem will need to adapt for this new learning platform. For example, Neti should maybe consider GraalVM as a new, SubstrateVM as a new platform and adapt itself based on that. But GraalVM needs also to evolve to be able to support more libraries. Spring Framework 5.1 ships with initial GraalVM support, and we will continue to refine that support in Spring Framework 5.2. But we have begun to add support for that kind of application. And the interesting thing is that even with a regular Spring Boot application, configured in a functional way, because regular annotation-based application does not work yet on GraalVM, but Spring Boot application using functional configuration start to work on GraalVM. You can see that we can start a Spring Boot application in 6 milliseconds. So that's really what I'm talking about when I'm talking about instant startup. It starts really, really, really fast. OK, so let's have a demo. And for that demo, I would like to use something that is more than just an hello world, because I think that's a new game. Every framework claims, OK, yeah, we run fine on GraalVM, and that's perfect, and no more detail. It's clear that you will not use tomorrow GraalVM in production with any framework available, because let me just take the example of the logging. Logback is not working. log4j is not working, and even Java util logging is not working. Okay, so this is an ongoing process. SubstrateVM team is doing quite a great job to handle the feedbacks, but it's not ready for production yet. But it's worth to anticipate, collaborate with the GraalVM team to make sure that most of the ecosystem run better on GraalVM. So, okay, so let me switch to the Jafu one. So this is a Spring Boot application with Jafu configuration. Okay, so this is a functional and declarative approach, but with Java. Here I'm declaring my data configuration, my web configuration. I'm still using R2DBC, but this time with the Reactive API. Okay, so I'm directly using database client, which is directly provided by Spring Data R2DBC. I'm having an API with mono and flux instead of suspendable function. The web part is using WebFlux with Netty, Jackson, the same kind of programmatic computation of the port with the syntax a little bit different, but basically that's the same that we have seen previously, but with Java and Reactive API instead of coroutines. And what we are going to do is to compile this application with SubstrateVM. So to do that, I have to use a configuration. So this is configuration for reflection. So every class created by reflection needs to be configured. For now, I have written this reflection configuration by hand. I expect for that to be really usable in production, that at some points, this configuration will be generated automatically. Maybe GraalVM team will provide some tools about that. Maybe we will. Maybe something will arise from the community. But I don't think it will be usable before we have some tooling to generate automatically this configuration. So here I'm specifying basically the classes and the methods that are called. So there is that for my application. There is also configuration for Netty, for log4j, for framework, for boot also. So yeah, we provide that to the native image compiler, which is here. So when I want to compile a JVM application and a Spring Boot application for SubstrateVM, I just build it with Gradle. Okay, this is a normal Gradle build that will generate a regular Spring Boot jar. And then so I'm using a SubstrateVM master because I'm using some latest improvements. So I'm basically specifying the included resources. I'm using this new option, which is allow incomplete class path, which is a feature that we have asked for a long time to GraalVM team. So thanks to them for providing that. Before the upcoming GraalVM 1.0 RC10, as soon as you had a class that was not in the class path, and in every framework, not just Spring, that happened, basically GraalVM crashed saying, okay, class not found exception. So now we have this option that will be super useful for all the ecosystem that allow GraalVM to be lenient about classes not being in the class path, and that basically solve half of the issues we had with GraalVM. We can also delay class instantiation, etc., etc. So, okay. And then I specify the main class. Okay, so let's run this. So I'm going to compile it. So the first step is to compile my project with Gradle. Then I extract the included jars and classes from the Spring Boot fat jar. And then I have a compilation. So it's funny because my program is running and compiling at the same time. In fact, SubstrateVM is currently running my program based on the bytecode to translate it to native code. Okay, and so it's basically interpreting all my bytecode to generate something which is native. You have a bunch of warning message because yeah, there is some classes that are not in the class path, etc. But everything should go fine, at least I hope. And you can see that it takes some time. So SubstrateVM is not about something you will use for development. Okay, this is something that you will use for compiling your program to deploy it in a Docker image, for example, or in another place at the end of your deployment. static executable compilation take time. So you will have, I think, 1 minute basically to compile a Spring Boot application. Okay, so now I have my compilation that is okay. So now you can see that I have 46 megabyte executable that contain the GVM part I am using, the Spring Boot infrastructure I am using, and your application. And to run it, I'm just running it like that. So you can see it starts instantly, and I should have choke, I think that's on the root. Okay, so here it's just a simple demo, but what we have in this demo is PostgreSQL with a reactive database driver via Spring Data to DBC. Then we provide the result in an asynchronous and reactive fashion to Webflux and Netty, and we deserialize the data with Jackson. So that's pretty all that with Spring Boot infrastructure used in a functional way. So I think that's and it's beginning to be interesting that we have this full stack example on a reactive manner running as a native executable. And even if it will take time to mature, I think that's quite promising. Okay. So I think it's time for the conclusion. So in terms of roadmap, the roadmap is to incubate Kofu and Jafu DSL in Spring Fu. It's also to mature coroutine support, and we will try to provide that into Spring Framework 5.2 if the coroutines team provide us the the cold stream support we are needed. We are going to improve GraalVM native image compatibility both by improving Spring Framework and Spring Boot to make it more compatible with SubstrateVM, and also by collaborating with the GraalVM team. So we try to provide issues, repo projects to be able to run most of this ecosystem, because Spring Boot is not just about Spring, it's the integration point of the whole ecosystem, and we will try to work with them to get all the dependencies most of the dependencies that we integrate in Spring Boot working on SubstrateVM. Kotlin DSL from Gradle support should arrive on start.spring.io, because Gradle, which is historically using Groovy to describe your build, is now going to support with Gradle 5 Kotlin. So you have this autocomplete experience in your IDE. And also configuration properties data classes. I know that a lot of people are waiting for that. Okay, so immutable data classes support for configuration properties. We will really try to make it in Spring Boot 2.2, at least I hope. Now, before ending my talk, I would like to ask a question. I mean, it's nice with this declarative way and this functional way of declaring beans. My Spring Boot application is going faster, but should we really require all Spring Boot currently based on annotation application? I think it would be interesting. This annotation-based application benefit also for the functional beans improvement. So I have nothing to show today, but what I can say is that in order to reach this yellow or orange performance level with regular Spring Boot annotation-based application, we are working on a compile time Java config to functional configuration converter that could bring Spring Fu efficiency to any annotation-based Spring Boot application. This is still the early stage, but the idea would be to make it possible to have this level of performance with regular annotation-based Spring Boot application in the future. We are working on that, and we will communicate later about the result of these experimentations. Thanks a lot. Please vote and comment if you like the talk. You can follow me on Deleuze, and you can also provide your feedback, contribute pull requests, ask questions on the Spring Fu repository on GitHub. Thanks a lot.